Morning, good afternoon, and good evening, whatever time you are watching. My name is Yogesh, and we are doing Standard 12th Statistics Part 2, Chapter 1 Probability. Yes, so far, what we have done in probability. Yes, so far, you can see we have completed 13th sum in exercise 1.1. Yes, we are in exercise 1.1 and we have completed 13 sums. Okay, so now we are going to do with some number 40. Yes, let me read the question. The sample space U of a random experiment and its event A are defined as follows. Find the complementary event A dash of A. So what you need to find, you need to find complementary event A dash of A. Yes, what given in the question is U, that is from 0, 1 to 10, and A is given 2, 4, 6. So we are writing question first. Let me start with some number 14. U is equal to. Now what is U? It is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the U. Then what is A? So A is 2, 4, and 6. Now what question is? Question is to find A dash. As I told you what is A dash, you need to write all the elements other than A. What you need to write? You need to write all the elements other than A. Okay. So other than A is 0, 1. Will you write 2? Obviously no, because 2 is in A. Will you write 3? Yes. We will be writing 4? No. 5? Yes. 6? No. 7? Yes. 8? Yes. 9? 10. So this is my A dash. Very simple sum it was. Then let's move to the 15. Let's move to the 15th one. Now what is question in 15th one? Question is that U is given 0 to 1. Question is like U is X and X belongs to 0 less than X less than 1. So this is your U. So basically your U is between 0 and 1. Value of X is between 0 and 1. Then what is A? A is half less than X less than 1. A belongs to X belongs to half less than X less than 1. Now there is a sign of equal here. This half less than equal to X less than 1. Now what is A dash? So if I elaborate it, let us draw a line like this. Now let this line be starting from 0 ending to 1. Okay, so we are starting this line from 0 and ending to 1. Now exactly in this middle part, exactly here, there is half. Now they are saying that this portion half to 1 is in A. Now if this portion is in A, Then rest of the portion will be A dash. So what will be A dash? A dash 0 less than x less than half. We will be not including half in this a dash because half is already present in a. What is a dash other than a? So if half is present in a, half will not be present in a dash. Okay, so I think so you are clear now. So this is my answer. A dash is 0 to half. Okay. So we have completed this exercise 1.1. In the sequence of illustrations, we have completed 8th illustration as of now, and we will be doing illustration number 9. The events A1 and A2 of the random experiment defined as follows. Find the set showing the union event A1 union A2 and intersection event A1 intersection A2. Now this part is of the question only. Yes, they have not done the bold letters here, but this belongs to the question itself. Okay, this part A1 and A2. So you need to find A1 union A2 and A1 intersection A2. What given is A1 and A2. So let us start with illustration number 9. Let us directly write what is A1. So A1 is minus 1, 0 and 1. Then let us write what is A2. A2 is 1, 2 and 3. Now what is asked to you? You are asked to find A1 union A2. So A1 union A2 is we need to combine all the digits given, that is minus 1, 0, 1, 2 and so this is your A1 union A2. Then we are talking about intersection A1 intersection A2. Now what is intersection? The common element between A1 and A2. So intersection is 1. Your intersection is what? 1. So we have completed illustration number 9 also. You can see the answer. Union is minus 1, 0, 1, 2, 3 and the intersection is 1. Okay. Then come to last question, that is illustration number 10. A factory produces screw of the different length. The length in centimeter of the screw is denoted by x. The events A1 and A2 are defined as follows. The experiment of finding the length of selected screws. Find the event showing union and intersection. So this is your question A1 and the A2. Okay. As I told you that here they are not done boldly, but this is the question. So what is A1? Let us write the question. Illustration number 10. What is A1? A1 is 0 less than x less than 1. What is A2? It is half less than x less than 2. Now there is an equal sign in this half. So half less than equal to x less than 2. So as I told you, this is half less than x less than 2. Now what you need to find? You need to find union and intersection. Let us first draft this. We can solve this some easily. Let us make it line. Okay. Now this starts to from 0. From 0 to 1. This is A1. So this is A1 and this is A2. Yes. So this A2 is starting from half and going to 2. As I told you that half is in A2. We can do a circle that half is present here. Else anything is not equal to 0 is not equal to 1 is not equal to and 2 is not equal to. When I am talking about union of events, I am talking about specific union of events. Union, that means you have to consider everything. Everything, that means from 0 to 2, everything. Okay, from 0 to 2. A1 union A2 will be 0 less than x less than. Okay, so 2 will not be equal to, because in A2 equal is not there, and 0 will not be equal to, as in A1 0 is not equal to. In union, the element should be in at least one. Either it should be in A2, either it should be A1. Then I'm talking about intersection. Let's talk about intersection. So in intersection, it is from half to 1. So why so? You can see here intersection means common. So you can see from 0 to 1 it is common. Okay, it is common from 0 to, sorry, it is common from half to 1. See here also it is A1, A2, and here also it is A1, A2. So from half to 1 it is common. So I have written intersection here. Now 1 is not present in A1. You can see 1 is not present in A1. But half is present in A2. So when it comes about intersection, we'll be writing equal to here. Why so, sir? Because half you can see it is A1 also. Half is A1, it is between 0 and 1, and half is in A2 also. You can see that I have made a circle. So half is in A2 also, and half it is in A1 also. So I'll be writing half equal here, and 1 is not an A1. So we'll be not writing 1 equal here. Okay. So thus we have completed illustration 10 also. Yes, illustration 10 was quite important and bit difficult, so you need to pay attention. So we have completed exercise 1.1. Now, there is a work for you all. You have to write fair book. You have to prepare fair book. In that fair book, you will start from, yes, events. Then you are going to write illustration 1 to 10, and in that book you are going to write exercise 1.1, and you know in exercise 1.1 there are 15 sums. Okay, we have completed all. We have done each and every sum from starting of illustration 1 up to ending of 1.1. We have done everything in all the lectures. Okay, so just you have to write in a sequence in your fair book. It is not so that we have not done anything. Okay, we have done everything. So now today I am going to start a new topic, that is we are continuing after exercise 1.1 in the same lecture, and today my topic is probability. No sir, today you are teaching probability. What we were doing from these old days. From these old days we were constructing the base for the topic. From this all day, we will constructing the base for this topic. I was teaching you that what are the requirements to understand this topic. Yes. So what we have done till now, we have almost given 8 to 9 lectures to the topics of the base. Now that base was very necessary. If I wouldn't have teach you that base, you were not able to understand which I will be teaching you now. Okay, so now we are starting the probability. Whatever I taught you is it can be asked in 2 marks sum. Okay, by the way, there is no 2 marks heading in this particular chapter, but in 4 marks heading, there can be asked like 2 marks two question. I have told, I may have told you about the description of this chapter. That this chapter is of 12 marks. It's one MCQ, one short question, two 3 marks question, in one 4 marks question. Now in one this 4 marks question, they ask sometimes two questions of 2 marks. In the heading of 4 marks, that is section E. So it can happen. So you can get a sum from that. Yes. So today what I am teaching is very important. Today we will be doing what is probability. Now in simple terms, probability is m upon n. This is probability in simple terms. It is m upon n, very simple. Now, what is m and what is n? So, if I talk about n first, n is number of total outcomes. Okay, n is number of total outcomes. Now, total outcomes I have taught you that what are the total outcomes. If I toss a coin, total outcomes are 2. If I toss 2 coins, total outcomes are 4. If I toss a dice, total outcomes are 6. If I toss 2 dice, total outcomes are 36. Okay, so total outcomes I have taught you. What are the total outcomes? So n is total outcome. Then if I talk about m, now what is m? M is number of m is number of favorable outcomes. Okay, m is number of favorable. N is number of total outcomes and m is number of favorable outcomes. Now what is favorable outcomes? Yes, so as I told you that n is number of favorable outcomes and n is number of total outcomes. Okay, now let me explain you with an example. Suppose let's take an example. A coin is tossed and you are asked to find the probability that head is pink. A very simple question will be starting from a coin is tossed. Find the probability that head is obtained. As I told you that we'll always be starting with the n, that is total outcomes. Now total outcomes is your sample space. If I toss a coin, then there are two possibilities that there will be either head or there will be either tail. So now if I count this total possibilities, I'll get my n. As I told you that probability is m upon n. So this is your n. That is the total number of sample space. Okay, total number of outcomes. Now what is m? Okay, let event A be the let A be the event of getting head. Now let A be the event of getting head. Now what is head here? Head is only in single outcome. Find the probability that head is obtained. So head is in single outcome. So your m will be 1. So if I want to find the probability, my probability here will be my probability here will be m upon n, that is 1 by 2. You can write 0.5 also. If you write 1 by 2, it is fine. Okay? Answers are accepted in fractions and probability. So you can write 0.5 also. Let's take another example. A dice is tossed. Find the probability that it has number greater than. Dice is tossed. Find the probability that it is number greater than. As I told you, if a dice is tossed, first you have to focus on the total possibility. If a dice is tossed, total possibility is 1, 2, 3, 4, 5, and 6. So as I told you that there are 1, 2, 3, 4, 5, 6 digits. So your n is 6. Yes, your total number of. Now they told you that find the probability that is number greater than 4. So let A be the event greater than. So let A be the event greater than. Now what are the numbers greater than 4? When I say greater than 4, 4 is not being counted. If I say greater than 4, then there should be 5 and there should be 6. So number greater than 4 are, how many counts are there? Counts are 2. So if I want to find the probability here will be m upon n, that is 2 by 6, 1 by 3. Okay. So this is your probability, that is m upon n, that is 2 by 6. Okay. So that's it for today. We'll be continuing this probability in the next lecture.